Hello everybody and welcome to stage 3. So if you've tried the back side of this piece of paper, now's a good time to watch this video to see if you and I agree on our answers. Okay, let's read. New Ferris wheel, the radius is 30 feet and the top of this Ferris wheel is 75 feet above the ground. Okay, I always need to draw these things. So I'm going to draw a Ferris wheel right here. And then a little structure supporting it off the ground, and then this is the ground right here. Okay, so I know that the radius right here is 30 feet. Right? Yeah, 30 feet. Okay, now I know that the height from the top of the Ferris wheel all the way to the bottom, I know that this height is 75 feet. So my question is kind of like, well, I really want to know how tall this midline is, like the middle of it. And if I know that this distance right here is 30 feet, and I know that this whole thing is 75, then I think I know that's 30, and then this right here should be 45 feet. That's what I'm thinking right here, that this distance from the middle down to the ground is 45 feet. And just for good measure, I'd like to know what this would be, this distance right here. And if this thing is 45 feet and the radius is 30, I think I have 15 feet from the bottom of the wheel. So all right, I now know my the distance from the ground to the center of the wheel is 45, and the distance from the ground to the bottom wheel is 15, ground to the top of the wheel is 75. Now, the first thing that we're going to do is graph the vertical position, write the height equation. So, what I should do is think about this here. At 0 degrees, so right here on my Ferris wheel, right here on my Ferris wheel, on my diagram, I see that I am 45 feet above right here. Now, on this graph, I might want to label this, I don't know, 20, 40, 60, 80 maybe? 20, yeah, 40, 60, 80, sure. We'll do that. I wasn't planning on it, but we'll go for it. 20, 40, 60, and 80. Now we need to kind of highlight and keep in mind 3 things when we graph. We should keep in mind our midline, and that is so important that I'm going to put that in green highlighter right here. Green highlighter. So my midline, I know, is the middle of this Ferris wheel, and that's going to be 45 feet. So I'm going to put a little dot right here. Do this in a dotted line right across the entire thing. And since it's so important, I'm going to put some green over that so it jumps out. Okay, that is, and I'm going to kind of draw it back a little bit right here. I'm going to label this as 45 feet. And I'm going to label this as our midline. Okay? Now, the next thing is going to be the maximum. What is the maximum height right here? And that was actually given in the problem. That was 75 feet. I'm just going to put that as a dotted line. And so 75 feet, 1680 should be somewhere around here. So I'm just going to put a dotted line right here. This is my maximum height. I'm going to go this way, 75 feet. And can I zoom in a little bit? Oh, yes, I can. All right, 75 feet right there. And then this is going to be our maximum. All right, let's see if I can focus on this. Maybe. Still pretty bad. All right, so that's going to be our maximum and our midline right there. Now, the last thing that we should figure out is the minimum here. The minimum is going to be also a dotted line, just so we know. The minimum is going to be the lowest height, and that's why I wanted to find that 15 feet right here. 15 feet is the lowest height on that. So under 20 is around 15. I'll go to around right here. 0, 20, 15, sure. This will be my minimum height here. And I'll go back right here and label this 15 feet and our minimum. I don't know why I tried to spell that out. That was a bad idea. So we have our maximum, our midline, and our minimum right here. Great idea. Now, what I want to do is focus this so it's slightly more clear. Yeah, okay. When we are talking about verticals, now right here we're talking vertical position or height. The height. So the height starts off right here at 0 degrees, at not 0 I was going to say, but right at the midline. So at this point right here, we're at 45 feet. So this vertical position starts right here. Now at 90 degrees, it goes all the way up to the very top. It goes all the way up to our maximum right here. At 180, it comes back down to our midline, our 45 feet, right here. And then at 270, it goes all the way down to our minimum, 15 feet right here, 15 feet. And at 360, it's back up here at our midline right here. And let's make this a nice sine curve. And if we want to keep going, we of course could to 450 and back down to 450 just to prove that it doesn't stop there. It keeps going on and on and on and on. And you guys said on the front side of this that we use sine for vertical position. So let's do this. Our equation right here, our radius of this wheel, our amplitude is 30 sine of x. And then the middle of our Ferris wheel, our midline is up here at 45, so it will be plus 45. That's going to be our height function, okay? Our height function. Now, what we want to do is start thinking about our horizontal function right here. Our horizontal function will be down here. Now, our horizontal is going to make us think a little bit more. I'm going to redraw that that Ferris wheel drawing that I had up there just so I have it down here as well. So we have this, and we have, let's see, our midline right here was at 45 feet, and our radius is 30 feet. Top of the thing was at 75, bottom was at 15. Okay? That's our top, that's around our bottom here. All right, now here's our question. Our horizontal position is going to go in between the same midline maximum and minimum as above here. But let's just see. Our horizontal position right here starts off the radius length away from our middle. So we know that's going to be 30 feet. Okay? Then it goes up to our maximum, and that will get down to 0 right here. It goes down to our left side, and this will be a negative 30 feet, and down to the bottom, which is another 0 feet for our horizontal. So really what we see here is that it won't have the same max, midline, and minimum. I misspoke. It will only go up to 30 and down to negative 30. So I'm just going to mark that right here. 30 feet and down to negative 30 feet. At 0 degrees, right here, the horizontal position. Again, I am going to highlight that horizontal position right here. This distance is 30 feet. So at 0 degrees, we're starting at our maximum right here of 30 feet. And at 90 degrees, we're going down to 0 feet because there's no left, there's no right. It's just at 0 feet right here. 180 degrees, again, our horizontal position is that x value, that distance on the x-axis right here. We're at negative 30 for 180. 270 will go back up to 0 feet, and 360 we're back up at 0, which is here, okay? And here is our rough sketch. And again, we could keep kind of going on and on and on. I think you're starting to see some patterns between cosine and sine, but this is definitely our equation right here. Our radius does not change. Our radius does not change at all. So it's just going to be 30 cosine of x. Where's the 45, you say? When we're talking about horizontal movement, there is no need to think about how far up that Ferris wheel is. It's just depending on our radius here, okay? We'll have more practice on this later. Thank you very much, folks.